look, it's everyone's favourite part. It's modelling. I know there's some of you thinking, oh crap, not this. But yeah, it's modelling. But it's alright, I am here to help you. We are going to get through this. Let me go through this question. It's going to make more sense after I explain it to you, hopefully. So it says, the density of a pesticide in a given section of field P mg/m squared, so milligrams per meter squared, can be modelled by the equation blah blah blah, where T is the time in days since the pesticide was first applied. Okay, part A. Use this model to estimate the density of the pesticide after 15 days. What do you think you're going to do there? All you're going to do is substitute T equals 15. So if T equals 15, P equals 160 e to the power of minus 0.006 times 15. And all you're going to do is plug that into your calculator. And you get 146.2 milligrams per meter squared. Easy as that. Part A done. Let's move on. Part B. Interpret the meaning of the value 160 in this model. Okay, 160 is what you get when T equals 0. So P equals 160 e to the power of minus 0.006 times 0, which is just 160. So when it says interpret the meaning, 160 is the initial density of pesticide in the field. That's it. Nice and easy. Part C. Show that dP by dt equals Kp, where K is a constant, and state the value of K. Right. All you have to do there is differentiate your original function. So can you try that for me, please? So when you differentiate, you're going to do dP by dt 160 times minus 0.006 e to the power of minus 0.006 t. So you get minus 0.96 e to the power of minus 0.006 t. That is your format Kp. Okay, which means K is minus 0.96. Cool. Interpret the significance of the sign of your answer to part C. The sign of my answer in part C is a negative, which means my differential and therefore my gradient or my rate of change is negative. What does that mean? That means the density of the pesticide is decreasing. Density of pesticide is decreasing. That's your answer. If it were positive, that means it's increasing. The amount of pesticide as time goes on gets greater. But in this case, it's negative, which means my gradient is negative. So the amount, as time goes on, density decreases. Last one. Sketch the graph of P against T. Let's take all the information that we have. We have the initial amount. So we know our graph is going to start at 160. We know that it's a negative. So we know what way or what direction our graph is going to go. It's an exponential. So we have an idea as to what shape that graph is going to take, and we know it has an asymptote on the axis. Putting all that information together, we're going to have something like this, where this point is 160. The question says sketch. That is a sketch, and it's a fairly reasonable sketch. I've given all the information that I could have given, and that's it. That is how you do exponential modeling. Now, this question I picked specifically because a lot of questions follow that exact format. You're going to find a question which says interpret the meaning of something in the model. Since they follow this format, you kind of can quickly figure out what to do. Just do enough questions and you should be okay. But there you go, modeling.